Greetings of the day. This is an introductory lecture on artificial intelligence. Here in this particular lecture we'll be looking at definitions of AI. AI is a difficult topic to define and summarize in today's day and age. So we are going to look at 4 different schools of thinking, and in particular one particular thought by a computer scientist named Alan Turing, who had described AI in the 1950s, and that's a strong definition that we carry forward even to this day and age. So when we look at this particular quadrant and why we are so obsessed as a society to define artificial intelligence is largely because we have to look at many different perspectives of human reasoning. So when we look at this particular table, we are looking at 4 different quadrants. So the ones on the top here are to do with process as well as reasoning, and the ones at the bottom are to address the behavior. Okay, and the ones towards the left are to particular ones which deal with fidelity to human performance, and the ones to the right are to do with rationality. So these are the 4 different perspectives from which we will address the definition or trying to define artificial intelligence. So the first quadrant is how we can think as a human. So is it possible that the process day-to-day things like decision making and problem solving, is it possible for us to largely automate that? That would be thinking humanly to a large extent. The second quadrant on the right talks about our thought process rationally. That means, in the sense, is it possible for us to perceive, reason and act on a particular problem? So these are the first 2 our thought process of looking at artificial intelligence. And the third quadrant towards the left talks about acting humanly. Okay, and that this is the most interesting approach towards artificial intelligence, is that is it possible for the computer to mimic what humans do on a day-to-day basis? So this is where our interests lay in terms of implementing artificial intelligence in today's society. And lastly, the last quadrant is lastly to do with acting rationally, and that would be something that we would expect our AI systems to evolve and reach in a couple of years' time. Okay, so let's take the first approach. So Alan Turing, he proposed this idea in 1950, and this is to do with the third quadrant there, is how we can act humanly and approach artificial intelligence. So one of the experiments that he suggested back in that day was that we'll place a computer in one room and a human in the other room, and we'll place a sort of a screen in between, so that the human is not aware if it's a computer or a human on the other side of the room. And as the interactions takes place between these 2 individuals in the room, if the computer is able largely to mimic a human's behavior, then we would consider that particular computer to be artificially intelligent. Okay, and this was Alan Turing's way of looking at AI, and largely to a large extent we have sort of to some extent we can say satisfactorily we have reached Alan Turing's definition of AI. So let's look at what are the things that we should be able to achieve if you have to pass the Turing test. So if any machine passes the Turing test, according to Alan Turing, that would be considered as an artificially intelligent system. So the first thing that we would like to have is that it should be able to process our natural language. That means it should be able to largely understand, comprehend what we speak. It should be able to react to the sentences or to the words spoken. So there NLP would come into place. And NLP, as we know, is something that we have progressed over the years, and we have seen large scale applications of natural language processing even in generative AI, like the chat GPT and all the other sort of technologies that have come forth. So that's an evolution of NLP, and today we are at an age where NLP is playing a leading role in implementing artificial intelligence. The second and the most important part is how to represent knowledge, and this is something that we have been trying to deal with for a long period of time. So to summarize what happens when you represent knowledge, if you take a day-to-day activity of a human, there are many sort of tabs open in our brain. Okay, we have to think about how, for example, if I have to commute to my college, how far is a college. I would also take into considerations my past experiences of traveling to college. So with that, I have a rough estimate of the time taken. So this is knowledge represented in my brain, and with that information I will be able to make a decision. Okay, that means we are actually moving into the first quadrant here, that is thinking humanly. Okay, so how to represent that knowledge. So knowledge representation, we have come quite far in terms of understanding how to represent knowledge, and to a large extent knowledge representation in a system is something that is temporary, used for that particular period of time and then discarded away. So knowledge representation is something that the artificially intelligent system is supposed to do. And the third one is automated reasoning. That means with this knowledge that you have represented, you should be able to reason to the problem that is being asked. Okay, almost like a Q&A system, and the reasoning part is something that it's something that in the initial years we thought of in terms of writing rules and then expecting the system to answer based on that particular question asked. Now as we all know, if you look at AI, the most popular form of AI is statistical AI, and now we are able to answer those questions with statistical information, and that is something that we have come or advanced further. And the next part is machine learning. Okay, and ML is, like I said, with statistical AI we have come very far in terms of supervised machine learning methods. That is, we have been able to train a large number of data set and then query on this particular data set, and it's able to predict with a good score, whether it comes to processing images, whether it comes to processing text, whether it comes to processing speech. So we have gone far there. Computer vision, as we all know, is something we have come light years apart, because we are able to send cars onto the road with the knowledge that the artificially intelligent system is able to process the images or the video that it is able to visualize. So that's computer vision. And finally, the most important aspect, if you're going to act humanly, is that robotics should come into place. That means we should be able to manipulate objects and move according to the reasoning, the automated reasoning we have made. So this is what you call it in brief, what Turing's test is supposed to achieve. And there are many systems today which to a large extent is able to achieve what Alan Turing had defined many years back. Okay, and this is a good indication that we have been able to evolve as a society to achieve artificial intelligence. Thank you.